80% furnaces use 80% of the fuel and 20% of the heat is lost out to flue. 90% furnaces use 90% of the fuel and 10% of the heat is lost to the flue. This is all because of the addition of a secondary heat exchanger in the 90% furnaces. A 90% condensing furnace is a safer choice as the combustion is sealed and draws outside air for combustion and exhausts the flue gases outside. An inducer motor draws the burned fuel through the primary heat exchanger and then through the secondary heat exchanger to extract more heat from the fuel. This negative pressure inside the heat exchanger draws in air if any cracks or holes develop in the heat exchanger, instead of allowing the products of combustion to go out of the heat exchanger into the airstream that goes into the occupied space. Although the 90% condensing furnace is much safer, a carbon dioxide alarm should be installed in the home. So in an 80% furnace, you would only have the primary cells, and in a 90% furnace, you would have the addition of the secondary heat exchanger below the primary cells. When changing out a primary or a secondary heat exchanger on a gas furnace, you should have a complete breakdown of what all is involved in that primary and secondary heat exchanger. There are baffles that are in place to direct the air around the heat exchanger, and if these baffles are not replaced with the heat exchanger, there could be overheating issues. So always when you get a kit to replace the heat exchanger, the primary or secondary, make sure that you have a document that shows you the complete breakdown of all the parts that need to be there to make the furnace operate correctly. A very common call that we get during the winter in tech support on Carrier and Bryant 90% furnaces of older vintage is the missing rear air baffle. This baffle is placed on top of the secondary heat exchanger in order to direct the air towards the front of the heat exchanger so that when the air passes over the high limit switch, it is a temperature which will keep the furnace running. As you see, this rear air baffle can get corroded and rusted, and many times it may not be there when you do the service on the furnace. So if you don't have a parts list or a breakdown to show you this rear air baffle is necessary for that particular furnace, many technicians replace the primary and secondary heat exchangers without putting the rear air baffle in, and they immediately have high limit switch trips because that rear air baffle is not there to direct the air towards the front of the furnace. Technicians need to be aware of what a good heat exchanger looks like compared to one that is defective. This heat exchanger on the right is out of the box and is brand new, and it has the black coating that they use to seal the panels into the front plate of the heat exchanger. Many times this coating can also restrict the flow through the heat exchanger, so when you are changing a heat exchanger, make sure you double check and make sure that the coating is not restricting the air through the panels. This one on the left is definitely a defective heat exchanger, as there is a lot of rust and corrosion and buildup in the panels that is restricting the airflow through the secondary heat exchanger. This heat exchanger would need to be replaced. This is another example of a badly corroded and rusted secondary heat exchanger. And in order to see this, you would have to take the furnace apart to examine the heat exchanger. So before you do that, you need to make sure that the furnace is in a state which needs to be opened up to take a look at the secondary heat exchanger. Taking a furnace apart to take a look at the secondary heat exchanger is a very labor-intensive endeavor. Before you start tearing the furnace apart, you want to make sure that it is something that needs to be done. By taking a CO reading in parts per million on the exhaust of the furnace, you can tell whether you need to open the furnace up or not. If the exhaust is under 10 feet, you can probably take the CO reading at the termination point for the exhaust at the outside of the home. If it's over 10 feet or 30 or 40 feet long, it is recommended that you drill a hole 12 inches from the inducer motor and insert your probe to take the reading. We also recommend highly in these videos that any home that has a gas appliance installed in it should have a carbon monoxide sensor installed. Many manufacturers have a checklist, which is a very good idea when you're doing a combustion test on a gas furnace to determine whether the secondary heat exchanger is defective or not. These checklists take you through the process and make sure that you're not missing anything. So when is it necessary to open up a gas furnace to check out the secondary heat exchanger? Normal furnace operation should be well below 100 parts per million. Any reading over 100 parts per million tells the tech that it is time to open up the furnace and see what is going on in the secondary heat exchanger.
Go to Airefco.com for more videos. Like, subscribe, and check back every week for new videos.